Okay, so completing the square is our second method for solving quadratics. And the goal of completing the square is that once we find the factors of a perfect square trinomial, we can easily square root both sides. So the reason we're trying to find these perfect square factors here is so that we can square root both sides. So in this first row here, these are already done as perfect square trinomials. Notice 4 times 4 equals 16 and adds up to 8. 3 times 3 is 9 and adds up to 6. 6 times 6 is 36 and adds up to 12. So these are showing you that if you have the factors of a perfect square trinomial, that you can then convert it to the factors and easily take the square root of both sides. This would leave me x plus 4 is equal to plus or minus 3. And so we get negative 4 plus or minus 3. And since this plus or minus 3 is a whole number, I can then write out my two roots. There's the negative 4 plus 3 root, which gives me negative 1. And then there's the negative 4 minus 3 root, which gives me negative 7. So these two roots were easy to be found because this 3 was a nice whole number. Let's go look at the next one. Here I've got the x minus 3 perfect squares because negative 3 times negative 3 is positive 9, and negative 3 plus negative 3 equals the negative 6. Now I can easily take the square root of both sides, and that gives me plus or minus 5. When I add 3 to both sides, 3 plus or minus 5. Because 5 is a nice whole number, I can get these two roots. There's the 3 plus 5 root and the 3 minus 5 root. So 8 and negative 2 are my two roots, my two solutions. Over here, I've got the x minus 6 perfect square. If I take the square root of both sides, I get plus or minus 7. When I add 6, I get 6 plus or minus 7. So 6 plus 7 is 13. 6 minus 7 is negative 1. My two roots are 13 and negative 1. Finally, in this one, there is a 2 that can divide out of everything before we get started. Notice that there's a leading coefficient. I'm trying to find a perfect square of 1x squared only. So x squared minus 6x plus 9 is equal to 16. And now this is exactly like the same over here of the x minus 3 perfect square. I take the square root of both sides. X minus 3 is equal to plus or minus 4. 3 plus or minus 4. We get the 3 plus 4 root or the 3 minus 4 root. 7 and negative 1 are my two roots. So again, once we already have these perfect square trinomials, we can easily put them into their factors and take the square roots of both sides. So now I'm trying to get you guys proficient at finding how to complete the square, what number will I be adding to both sides, so that we can then convert to the perfect square factors and square root both sides. So let's go do this second section of how do I find that missing c value. So the b work is taking the middle term, splitting it in half, and squaring it. So we're going to be using a formula of b over 2 squared. Why am I taking half of b? Because I'm creating a perfect square. If I'm extending on one side a certain number, I have to extend on the other side the same number. It's a square. So whatever that middle term is, it has to extend on both sides, so we need to split it in two for the two sides. So we get 8 divided by 2, which is 4, and 4 squared is 16. Remember that it's 4 times itself to give us 16, so my c value here is just 16. Here I go again. B divided by 2, and this time my b is negative 22, so I get negative 11 squared. Remember, negative times a negative equals a positive. Your c value of a perfect square trinomial is always going to be positive. So this b value comes from this true formula, and the c value of a perfect square is always positive. All right, take in the next one. 16 divided by 2 is 8. 8 squared is 64. My C value is 64. Now, in these two cases, you're going to notice that your B value is odd. When your B value is odd, it makes a fraction, an improper fraction. We can still square an improper fraction. 3 squared would be 9, and 2 squared on the bottom would be 4. So in this case, my C value is 9/4. So negative 9 over 2 squared. Negative times negative equals positive 81. My C value is 81/4. So it is possible when your middle term, so when the B value is odd, you can still square it to get a fraction. Now, the true nature of this is that the whole reason I use completing the square is when it's convenient to easily make a perfect square and to convert it into the perfect square factors. When we have an odd middle term, honestly, I wouldn't choose complete the square, but I do want you guys to understand that you can do it. It just makes a fraction. It's not my preference. We're going to talk later about a third way of solving quadratics that I would use instead. All right, let's go through the entire process now that we know how to complete a square and that our goal is to try to get those perfect square factors. So I start by making space to complete the square. Now I'm going to do the B work. B over 2 squared is going to be 4 over 2 squared, which is 2 squared. Some of you are actually writing 2 squared in when you write this. Some of you are writing the actual 4. Either way is fine. The goal of why we did this is to find the perfect square factors of this completed square. So I wanted these x plus 2 squared factors. And on this side, I'm left with 5. Since root 5 is not a perfect square, I can't do anything more with that radical. So I'm just going to solve leaving it in that radical. And I get negative 2 plus or minus root 5. If asked to split these into two answers, I could say that there's the negative 2 plus root 5 answer, and there's the negative 2 minus root 5 answer. These are my two roots, my two solutions, my two zeros. Okay, let's go over here. Step 1 is to make space on both sides for completing the square. Do your B work. So negative 10 split in half is negative 5 squared. So some of you write in the negative 5 squared here. And some of you write the actual plus 25. Why is it positive? Because the C value of a perfect square trinomial is always positive, because negative times a negative equals a positive, and positive times a positive equals a positive. So either way, this should always be a positive C value. 25 minus 10 is 15 on this side, and this made the x minus 5 perfect. Why is this a negative this time in the middle? Do you see why this one actually has a negative sign? Square root both sides. Since 15 cannot be simplified anymore, I'm going to leave this in radical form, and I get 5 plus or minus root 15. If asked for both factors, there's the 5 plus root 15 answer and the 5 minus root 15 answer. Now, notice on these two, the constant was already on the right-hand side of the equation. Here, I have to add the 9 to move it over to make my space to complete the square. So be careful when there is a constant on the left side. You're going to want to do inverse operations to move it over. Now let's go do the B work. This time my B is negative 2. Negative 2 divided by 2 is negative 1 squared. Some of you are writing the negative 1 squared. Some of you are writing the plus 1. Okay, -1 times -1 is +1. That's where that came from. On this side, we get 10. And on this side, we have the x minus 1 perfect squares. Square root of both sides. Add 1. 1 plus or minus root 10. Because the 10 cannot be simplified further, I'm done. If asked for both roots, I would say that there's the 1 plus root 10 root and the 1 minus root 10 root. Two kinds of perfect square roots. All right, I'm going to go to the back side now. We still had to do numbers 13, 14, and 15. Okay, so I'd like you to try these two on your own after seeing me do those other two examples. I am going to do this one because it has a number in front. Remember on these two to first subtract the constant to move it to the other side before you complete the square. On this last one, it's able to be divided by 3 on all the parts. Leave space to complete the square. 3 goes in once, 14 times, and this is a -14. Okay, so on this one, what am I going to be adding to both sides? Off to do the b work. Notice I'm doing the b work on the new reduced b. So I'm getting 6 squared, so I'm getting 36. Some of you like to write the 6 squared. Some of you like to write the 36. Either way works. This gives me the x plus 6 perfect, -14 plus 36 is what you're really doing, and that leaves you 22. Take the square root of both sides. We get x plus 6 equals plus or minus root 22. And since 22 cannot be reduced any further, it's just done. If asked to give both answers, I'd say -6 plus root 22 and -6 minus root 22. Okay, try 13 and 14 on your own. Let's see if you're starting to get the hang of it.